Hello everyone, Homer White here for the first part of our screencasts on Chapter 9, Lists. What are lists? So far all the vectors that we've dealt with in R are atomic vectors. All the elements had to be the same type. And so you had, the double type, you had the logical type, the character type, and the integer type. But there also exist data structures in R that are vectors, but they're non-atomic in the sense that their elements don't all have to be the same type of data. One such is a list, and you can create a list using the R function list. And what you provide are the elements of that list separated by commas. You can give names to the elements. The name comes first, then an equal sign, and then the value. So that element that's called name is just the character vector of length 1, quotes Dorothy. And the element called age is the double precision vector of length 1, the number 12. The name list 1 is being bound to that in your global environment. Try it out. And so if you were to evaluate LST1, then you would get a printout to the console giving the names after a dollar sign and then the values underneath them. So lists are like data frames in the sense that you can access the elements in them using the dollar sign notation. Here's another example. Let's make a data frame. And it's just going to have two columns, one called X and one called Y. And the first column is 10, 20, 30. And the second column is going to be lowercase ABC. And we're binding the name DF to that data frame. And LS2 shall be a list where the first element is called vowels, and it's the lowercase vowels in the English alphabet. And the second element is my frame, and it is that data frame. And so if you were to evaluate LST2, then again, you have a list with two items, but that second item is kind of complicated. It's a data frame. Here's another example which shows that you can use a list you've made to be an item in a list that you plan to make. The name list3 is going to be the result of calling the list function to make a list where the first element, called nums, is the whole numbers from 10 to 20. Second element, called bools, is true, false, false. And the third element, called George, is the LST1 that we made earlier. And so a printout to the console of LST3 shows this complexity. Here's the first element with its name. Here's the second element with its name. And the third element is named George, and its value is that data frame. The first column here is that, its value is that LST1. And LST1 had a name and an age element in it. The name element was Dorothy. The age element was the number 12. You can also make an empty list, just the function called list with no arguments provided. And so when you try to print it out, it doesn't look very interesting. How do you get at the elements of a list? So this brings up the notion of subsetting, just as with vectors. So if a list element has a name, then you can get at it with the dollar sign. Like list 1 had an element named name and an element named age. List 1 $age is that character vector of, is that double vector of length 1. If you've got a list that's an element of another list, then you can keep stacking the dollar signs together to get at the element. So list 3, remember, its third item was named George, And that was a list that had two elements in it, one called name and one called age. So we're getting the age element inside of the George list that is inside of list 3 here. There it is. To take subsets of a list, you can use the square brackets operator, just like you do with vectors, because lists are vectors, they're just not atomic vectors. Keep in mind then that just as a subset of a vector is another vector, a subset of a list is going to be another list. So list 3, square brackets 1, 2, returns a list whose elements are the first and the second element of list 3. Here we're asking for a list whose elements are just going to be the first element of list 3. And so that's just the nums vector. So here's a list with one item named nums, and it's the numbers from 10 to 20. So keep in mind, subsetting a list always yields another list, even when you've subsetted down just to one element. So you might wonder, how do we get at the element itself instead of just a list containing the element? And so there's two ways. One way we already know about, and that's using the $ idea. Name of your list, $, name of the element inside of it. And then you get down to just the whole numbers from 10 to 20. But R provides another convenience for you, the double square brackets operator. And so if you put the 1 inside double square brackets after LST3, then you get the contents of that first element of the list. Now remember, LST1, it's a list of two different types of things, a character vector of length 1 and a double precision vector of length 1. If you wanted to flatten out the list to be just a vector again, a regular atomic vector, then you can use the function unlist, just apply it to a list. But what R is going to have to do is it's going to have to coerce the values to be all of the same data type. And so when it meets the double precision and it meets the character vector, it says character vector wins, and it produces this character vector of length 2. So it turned the number 12 into the string 12. Notice that it did preserve the names that came from the original list. We show a little application of lists, splitting. So remember M111 survey from the BCSC-R package. So if you've restarted your R session, if you've restarted R recently, you might want to library BCSC-R to get at M111 survey. Suppose you wanted to make 3 separate studies, one for each of the groups of people who prefer to sit in a particular place. One for the front sitters, one for the middle sitters, one for the back sitters. You might want to have 3 different data frames. And you could type out this code kind of in a slow way. So front data frame shall be subset of M111 survey, where your condition is that seat has to equal 1 front, and the middle and the back data frames defined similarly. But that involves, typing out or copy pasting 3 very similar function calls. Is there a way to do it all at once? And yes, there is. There is a split function. And if you give it a data frame or some other list-like object like that, and then a second parameter is the factor by which you'll do the splitting on, and that's going to be by the values of the seat variable in M111 survey, then got the name by seat bound to the result of that call. Looking into the structure of by seat, you'll see it's a list of 3 items. And the entire printout is quite long, so this is just a little bit of it. But the first item is called one front, and it's that subset data frame of everybody who prefers the front. Remember, there were 27 people who preferred the front. There's going to be a second element not shown in the printout, just try it in the console and you'll see, called to middle, and it's a data frame consisting of 32 rows, the 32 people who prefer the middle. And there's a third element in the list called 3 back that has, I believe, 12 people in it. So this would allow you to get at the 3 data frames simply by, you would think, simply by naming your list, then the $sign, and then the name of the element in the list. Unfortunately, there's an error if you try that, and that's because 1_front is not a legal name in R. Remember, you can't have variable names starting with digits. So how do you handle that? There's a couple of ways. R allows you to use the double square brackets along with that illegal name in quotes. So you can always do this. You can take your name, put it in quotes, whether it's legal or illegal, and use the double brackets, and you'll be able to get at that element directly. Or you could just remember what number place that element is. So the one front frame is the first element, so you can do double brackets 1. So that's a couple of ways to get around it. That's the end of our presentation for part 1 on lists. I'll be back soon with another installment.